Okay, so the last time we left off, we talked about the transistor. Okay, we talked about transistor and the working principle of a transistor. Okay, of course, the most important thing when we talk about the transistor is that uh, is that first there are three legs lah. Okay, there's the collector leg, there's the base leg, and then there's the emitter terminal. Actually, terminal not leg. Okay, so because of that, we also learned that there are two circuits lah. One is the collector circuit and one is the base circuit. Okay, now the basic working principle of a transistor is that a transistor works as a switch lah. Okay, so it's either switch on or switch off. But in order for it to switch on, the base circuit has to have enough voltage. Okay, has to have enough voltage that is bigger than the junction voltage. Okay, this is the most important thing. The base voltage must have a voltage that is bigger than the junction voltage in the transistor. Okay, and we talked very long about what is the junction voltage and why is there a junction voltage and blah 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 blah. Okay, but basically a junction voltage is like a gap. Okay, it's like a gap that stops the electrons from crossing over. And if the electrons cannot cross over, current cannot flow. Okay, that's the basic of this. Okay, so the junction voltage is a gap. So you need a bridge, okay, in that sense, or you need to give the electrons enough energy so that they can jump over that gap. Okay, and when they jump over the gap, current can flow and the junction becomes smaller. So this is the very, very basic thing. Okay, the base current, okay, if the base voltage is big enough, current can flow. And if the base current flows, then the collector current can flow. Okay, but in comparison, the base current is very small compared to the collector current. Okay, ini mesti kita fahami ini. Okay, and this is the amazing thing lah. Okay, this is the amazing thing that, you know, such a small thing controls such a big thing. Okay, so, and then after that you can calculate the current amplification and so on and so forth. But this is probably the most important thing that we need to understand. A small change in the base current will cause a large change in the collector current. So this base current or the base voltage over here serves a dual purpose. Number one, it serves to turn on the collector current. And number two, it serves to amplify the collector current. Okay, so the collector current is just like the byproduct, you know. Dia macam, okay, saya tertakluk kepada syarat lah. Kalau syarat dipenuhi, baru saya boleh jalan. Okay, so the base current is the most important thing. Okay, in this case. Okay, but this is an example of a very basic circuit lah, provided that you have two voltage sources. Okay, but usually what happens okay, when we talk about an automatic switch lah, okay, usually what we will see is this kind of circuit where you only have one voltage source, okay, but two resistors. So you no longer have a situation where, you know, there is another voltage source at the back over there lah. Okay, so this is what we want to look at today. We want to look at the transistor and the circuit of an automatic switch. Okay, remember, automatic switch is, you know, if there is a big enough voltage, it will jalan. Okay, the transistor will turn on. Okay, if there is a big enough voltage. That is the basic thing you must use. Okay, so let's start with this activity 3. Name the type of transistor used. How to know the type of transistor? We look at this arrow. If the arrow is pointing down, it will be, oh dear, sorry, it will be an NPN transistor. Oh no. Okay, sorry, NPN transistor. Okay, how can you relate V1, V2, and V? Okay, so this one is V, okay, the big V over here, which is the 6 volts, equals to voltage 1 plus voltage 2. And we know this from chapter 3. Okay, chapter 3 in electricity, we learned that if the two resistors are in series, the voltage is divided among the two of them. Okay, according to how big their resistor is. But the total voltage, okay, is equals to the voltage provided. Okay, resistor in series. Okay, just to remind you, resistors in series. Okay, voltage divided are not necessarily divided equally, okay, depending lah. The bigger the resistor, the bigger the voltage lah, okay. But the current, okay, current is the same. Okay, resistors in series. So the current that is flowing in here and the current that's flowing in here is the same current. Okay, it's just that the voltage is different because of the different resistor. The bigger your resistance, the bigger the voltage, because you need more energy to go past the resistor. Okay, kalau kamu ada penghalang yang sangat besar kan, kamu memerlukan lebih banyak tenaga lah untuk melepasi tenaga tersebut. So obviously you need a bigger voltage. Okay, but whatever it is, the voltage over here plus the voltage over here will equal to this big voltage. This is a very, very important relation. And we call this, okay, we call this a potential divider. Okay, so this is known as a potential divider circuit. Why potential divider? Apa yang kena bahagi adalah voltan. Okay, what is it called in Malay? Pembahagi, I think it's called pembahagi voltan or pembahagi keupayaan. I can't remember, but it's called a potential divider circuit. Okay, the old English textbooks will call it a voltage divider circuit. Okay, because it divides the voltage. Okay, tapi again I'm saying it's not dividing it equally. Dia ada ratio itu, bergantung kepada if the R is, you know, big or small. Okay, what can you say about the current that passes through R1 and R2? As I said before, the current must be equal because these are resistors in series. Okay, dia bersambungan. What is the relationship between R and V? Okay, R is directly proportional to V, or V is directly proportional to R. The bigger the R, the bigger the V. Okay, bila R makin besar, V makin besar. Ini semestinya lah. The bigger your halangan, the bigger the voltage. Macam saya terlampau awal cakap pula. Padahal soalan itu ada juga di sana. Okay, so again, these first few things are just facts that we need to understand before we go and understand about this circuit. Okay, now name a law that is involved in this relationship. Okay, it is Ohm's law. We studied this in chapter 3. Okay, now if R1 equals to R2. Let's talk about how the voltage or how the potential difference is divided. Kalau the resistance is the same, okay, then you will find that this 6 volts over here will be equally divided. Okay, because the resistance is the same. Okay, so V1 will be 3 volts and V2 will be 3 volts. Okay, because 3 plus 3 equals to 6. Okay, so V1 will be 3 volts, V2 will be 3 volts because the same potential difference here. Okay, if this is 6 volts, from here to here is 6 volts, from here to here also must be 6 volts. Okay, in these two resistors. Let's not talk about this, okay, this is nothing. Okay, let's ignore that first. Now, if V1 is 1 volt, if this is 1 volt, okay, how many volts will this be? This will be 5 volts. Okay, and that's what we call a potential divider. Kalau kamu tahu voltan sebelah atas, kamu tahu voltan sebelah bawah sebab you are given the total voltage which is 6 volts. Okay, so yes, it is called a divider, but it is not divided equally. Okay, dia just okay. You know, kalau kamu kurang rintangan, maksudnya saya bagi kamu sedikit voltan lah. Kalau kamu banyak rintangan, if you have a very high resistance, I give you more voltage because you need more energy, again, to pass through the resistance. If V1 is 5 volts, if this is 5 volts, naturally this one, you immediately know it will be 1 volt. No need to think, nothing to count one. 6 minus 5 lah, kalau kau mau sangat kira kan, fine. 6 minus 5 equals to 1. Okay, so that's how we understand the potential divider. Okay, this is the first and the most important thing we need to understand. Okay, is that when there are two resistors in series, okay, the potential okay, or the voltage okay, the voltage is divided according to the resistance, not equally. Okay, most importantly you need to understand. Because ramai orang kan, oh sini 6 volt kah, ada 2, jadi ini 3 lah. No, not necessarily. Okay, depends on the resistor. Kan? Depends on kamu punya kemampuan lah. You know, if you have very little resistance, you don't need so much energy. Kan? Okay, so please understand this concept, the potential divider. Now let's talk about how the potential divider circuit works. Okay, so again now we need to understand this. Battery voltage is always from point to point. Okay, so if this is 6 volts, yes, I know it's just one battery with 6 volts, but if say 6 volts, so it says 6 volts. Okay, take a look at these two. These two resistors are equal. Okay, two resistors are equal. So let's take a look first. Now, in a working circuit, a resistor R1 and a series resistor R2 are being used to form a potential divider. Okay, so if we want to use a transistor as an automatic switch without having a secondary power source, okay, if you look at this, I remember this one, there's another power source over here. What if we don't want too many power sources? Okay, so we can modify the litar supaya dia boleh jadi just one power source, but we have to provide two resistors so that we can divide the resistors according to their divide the voltage according to their resistors. Okay, let's complete this sentence. First of all, if the base voltage is 0, therefore there is no current in the base current, and there's definitely no this one, and so the transistor will be off. Okay, kita fahami ini dulu. Because remember, as I said, transistor can only switch on sekiranya the base voltage, okay, is bigger than the junction voltage. Transistor switch on. But now our base voltage is 0, lagi lah. Okay, it's definitely much less than the junction voltage. So no current flows in the base, no current flows in the collector, and therefore the transistor is switched off. Okay, so if the variable R2 is set to low, the base voltage is low and the transistor is switched off. Okay, the base current does not flow and the collector current also does not flow. Why is the base voltage low? Or what does this low mean? Okay, lower than junction voltage. Okay, ada voltan. Okay, you see okay, if the variable, if R2 is set to low, okay, kalau saya tetapkan ini bukan lagi 10 kilo ohm, let's say I say it's just 1 kilo ohm now. Okay, very less compared to this 10 kilo ohm, so it's low. So low resistance, remember the relationship we saw just now? V is directly proportional to R. If the resistor you set low, the voltage that is going to be provided here is going to be low. Okay, and when we say low, we mean lower than the junction voltage. So when the base voltage is lower than the junction voltage, the transistor is switched off, and so the base current does not flow and the collector current does not flow. Okay, why is the transistor switched off? We saw this last week lah. Sebab electrons tidak cukup tenaga untuk melepasi the junction voltage. Okay, that's what this means. Now, however, if the resistance of R2 increases, sebab ini adalah apa ini dipanggil rheostat. Okay, rheostat atau perintang boleh laras. This one the resistance can change because of the arrow. This one the resistance is a set resistance. Okay, dia tetap. Okay, dia adalah perintang yang tetap, so cannot change. But that one, the one down here with the arrow, okay, there is an arrow over here, so it's a change. You can change the resistance lah. So if you change the resistance and you increase, the base voltage will increase. The relationship we saw just now. R is directly proportional to V. Okay, so increase the resistance, the voltage will have to increase because you need more you need more voltage, okay, to pass through the resistance. Okay, now this is the key point. When the base voltage exceeds the junction voltage, okay, when the base voltage gets high enough so that it becomes bigger than the junction voltage, then there is going to be a current flow in the base, and that will cause the collector current to flow, and the transistor will be switched on. And if the transistor is switched on, there is current flowing over here, so this menthol will light up. Okay, so all that happens because the base voltage now is bigger than the junction voltage. Okay, base voltage bigger than the junction voltage, current in the base will flow, causes the current in the collector to flow, and the transistor will switch on so that it can just continue and continue and continue flowing. Okay, and so this is the summary of this. The transistor is off when the base voltage is small. Okay, the transistor is off when the base voltage is small and on when the base voltage is large. But I want you to add this lah, okay? Small is a very relative word. Okay, so we need to put smaller, okay, smaller than the junction voltage. And on when the VBE is larger than the junction voltage. Okay, dia mesti melebihi junction voltage, baru dia boleh on. Okay, but generally, generally, we understand that if the voltage is too small, okay, then the transistor will switch off lah. If the voltage is big, then the transistor will switch on. Okay, but secara detailnya, the actual explanation lah is that it's smaller, okay, smaller than the junction voltage and bigger than or larger than the junction voltage. Okay, everything depends on the junction voltage. Okay, if you don't have enough voltage bigger than the junction voltage, then the transistor will switch off because you don't give the electrons enough energy to pass through. Okay, now different semicons, so what is the condition for the base voltage to switch on the transistor? The base voltage must exceed the junction voltage. This one is the one that I mentioned just now. Okay, now different semiconductors. So there are two basic semiconductors that you learn in physics 1.5, which is silicon and germanium. Okay, now different semiconductors have different junction voltages. The most popular semiconductor is actually silicon. Okay, a lot of our electronics, a lot of the things that are inside your CPU or in your laptop, your handphone, you know, every single device that uses semiconductors mostly are made of silicons. Because silicon is cheaper than germanium. Okay, but because it is cheaper, the junction voltage for silicon is 0.7 volts. It has a higher junction voltage now. Means you need to provide it more than 0.7 volts in order for it to berjalan. Okay, and germanium is good because the junction voltage is very small. Means you don't even have to provide such a big voltage, and the germanium transistor will switch on. But germanium is generally more expensive because of its low junction voltage. Okay, I mean, you know, bak kata pepatah lah. If you want something that is of high quality, you have to pay money for it lah. Okay, if not, then you just, you know, settle for something a bit less lah. Okay, so generally we use silicons a lot. Okay, we use silicons a lot in our laptops, in our this one. I have heard that there are some, okay, and I'm not sure whether this is true. I have heard that there are some computers, the reason why they're expensive is because they don't use silicon semiconductors. They use, you know, a better quality semiconductor, germanium. Okay, and I'm not going to go into this, which one is better, which one is better. If you want to know, you can do this research yourself lah. Why is silicon better? Why is germanium better? But what we know is that there is a minimum junction voltage for silicon and a minimum junction voltage for germanium. Generally, in every question, we will usually refer to silicon. So it's better to remember this, 0.7 volts. Okay. Now, derive a formula to calculate the minimum, okay, base voltage to switch on the transistor using the potential divider method. So this is the potential divider, this one. Okay, V out here, how much voltage must flow here is equals to the resistance over the total resistance times with the input voltage. I repeat, how much voltage over here equals to this resistor over the sum of these two resistance times with the voltage. Okay, and so this is the long way of doing this lah. Okay, this is the this is the derivation. We start with Ohm's law. Okay, and then because the resistance is R1 plus R2, so I substitute this R over here. Okay, I equals to V over R1 plus R2. Okay, So R1 are in series, so I1 plus I2 lah. Okay, so the current is the same lah, doesn't matter. Okay, now this one, the junction voltage is IR2. Okay, because since the current is flowing here, the junction voltage is depending on this R2. Okay, so you can flip this around, okay, or you put in the I. Okay, I equals to V over R1 plus R2 times R2. And then you switch, you pindah around lah. Okay, so, okay, I just tukar this R2 and this V. Okay, and I will get this. Okay, but this is the derivation, not so much to worry, but this is the most important thing. Okay, so we call this the potential divider formula. Okay, if I want to count just this resistance, okay, and I have this voltage and this voltage, I know I can do it lah. Okay, R2, R2. Later we will look at a few examples and exercises to talk about this. Okay, but again, we can calculate how much voltage is over here so that we can compare. If it is bigger than 0.7, then we know that the transistor will switch on. If we calculate, then we see, hey, it's less than 0.7. Okay, then the transistor will be switched off. Okay, that's the most important thing at this beginning stage. Okay, because now we're going to go and look at two circuits. Okay, two very important circuits that talk about automatic switch. Remember, just keep in mind, okay, voltage must be more than junction voltage. Okay, and how to get a bigger voltage is to get a bigger resistance. So, another component, okay, that is very important is this thing called LDR. We call this a light-dependent resistor. Okay, so a light-dependent resistor, it is a resistor yang bergantung kepada cahaya. Okay, light-dependent resistor. So if there is light, okay, kalau ada cahaya, okay, kalau ada cahaya, the resistance is low. Okay, kalau dia gelap, okay, if it is dark, the resistance is high. Okay, so this one is dia boleh berubah-ubah dia punya rintangan depending on the time of the day lah. Contohnya sekarang dia adalah cahaya. So kalau kita letak, if we put this LDR in the light, okay, the resistance will drop. Okay, tapi bila kita bergerak dan kita masukkan the light dependent resistor, this LDR, into a dark room, the resistance will increase. Okay, and that helps us, that helps us. So the characteristic of the LDR is this: it has high resistance in darkness. Okay, commit this to memory because there's another resistor yang dia terbalik itu. Okay, so the variable resistor is, I don't know why this thing is terbalik, but fine. In a transistor circuit, the current does not flow in the collector circuit unless there is current flowing in the base circuit. Okay, so the transistor can function as a switch by turning the base current on or off. Okay, and how do you turn the base current on or off? You change the resistor, okay, so that the voltage will change. So the potential divider method, which we just saw just now, can be applied to control the base current to turn the transistor on or off automatically. Okay, so the variable resistor is used to vary the resistance and the voltage. So example, light dependent resistance, and the other one is called a thermistor. Thermistor kejap. Okay, kita tengok light dependent resistance dulu. So in an LDR, okay, as I said just now, if it is in a bright space, the resistance will be low. If it is in a dark space, the resistance will be high. Okay, that's why it's called light dependent resistor. Ada cahaya, ada light, resistance turun. Okay, now when we position the light dependent resistor, usually we will position it down here. Okay, let's take a look. So a light dependent resistor is a type of resistor. It changes its resistance with the intensity of the light. Tengok symbol untuk light dependent resistor. Dia adalah satu rectangle, one circle, and two arrows. Okay, the LDR resistance is high in the dark. Okay, and so in the dark, the LDR resistance is very high. It's repeating the same sentence. Okay, now if this resistance is very high, okay, kalau di dalam gelap, okay, dalam gelap, resistance becomes very high. What do we learn about resistance and voltage? The voltage will be bigger. Right? The voltage across this will increase. Okay, and so because of that, the voltage increase, it will increase lebih besar daripada the junction voltage. And that's the only thing we want. And we increase the resistance so that the voltage can increase melebihi the junction voltage. Okay, or the minimum base voltage lah. And so there will be current flow. And then the transistor will turn on, and then this causes the collector current to turn on and the bulb will light up. Okay, let me repeat. The order is always the same one, you know. Okay, high resistance, high voltage, lebih besar, the high voltage must be lebih besar lah daripada the minimum junction voltage. Okay, base current will flow, transistor will switch on, collector current will flow, and the whatever peranti yang kau letak di sini dia akan hidup. So the light bulb will light up. Okay, in the dark. Okay, so this is like in the dark, the bulb will light up. Okay, but this is the explanation all in the middle here. This is actually what is going on behind the scenes. Yang kita tahu, bila time gelap, lampu on secara sendirinya. Where do you see this happening? Lampu jalan lah, obviously. And if it is dark enough, the lampu jalan will turn on by itself. Have you ever at 12 o'clock in the afternoon, on a very rainy day, okay, kamu nampak juga the lampu jalan turn on? It's because there is a switch over there somewhere lah, okay, that has a light dependent resistor. The moment the light dependent resistor, dia dapat sense bahawa it's getting too dark, so it will increase its own resistance. Increase own resistance so that the voltage blah 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 blah, blah and then the bulb lights up. Okay, so previously, when you were not studying physics, you only know these two only. In the dark, the bulb will light up. Okay, but my question is, have you ever asked why lah? Kenapa? Why is it now that we're in the dark? How come suddenly the lights can turn on by itself? You know, siapa yang kasih on itu lampu jalan? No, it's not like satu pegawai pergi on satu jalan. No, it's not. Okay, it is the wonderful technology of the light dependent resistor. Okay, and the transistor lah, both of them in action. So you need to know, okay, you need to know what goes on behind the scenes. Okay, in the dark, light dependent resistance becomes very high. Voltage will increase sehingga melebihi minimum junction voltage. And when it melebihi minimum junction voltage, dia macam snowball effect tau. Minimum junction voltage, kau sudah memenuhi syarat. So what happens? Base current flow. Base current flow, collector current flow, transistor switch on, mentol will hidup. Okay, this form, dia memang snowball effect. All you need to do is just change the resistance. You change the resistance, everything else will follow. Okay, one way or the other. Okay, in the other way, it will be under bright condition. Okay, take a look at this statement and this statement, this statement and this statement, all terbalik itu. Under bright condition, the resistance of the LDR decreases. Okay, so because the resistance of the LDR decreases, the base voltage will be less than the junction voltage. Okay? Base voltage less than the junction voltage, no base current. No base current, no collector current, transistor switch off. Sorry, there is no base current flows to turn on the transistor. There is no base current. So transistor akan switch off. No collector current, bulb turn off. Okay? So dia macam, as I said lah, dia macam snowball effect. If you really want to understand how to explain this, start with the light bulb. Okay? I mean, if you're there, you can answer lah. Answer this for yourself lah. Why does the light bulb turn on? The light bulb turns on because there is collector current. Why is there collector current? Collector current is because transistor switch on. Why is the transistor switch on? Transistor switch on because base current flow. Why is there base current flow? Why is there base current flow? It's base current flow because the base voltage melebihi junction voltage. Why the base voltage melebihi junction voltage? Because the resistance increase. Why the resistance increase? Because it is dark. Okay, because it is dark. You can work it the other way around if it helps you to understand. Okay, or if you want to work it from start to the end also boleh lah. But when I teach this, okay, I have found that students, I mean, generally find it easier to work backwards. Somehow it's very funny though. If you work backwards, it makes more sense than kalau kamu bergerak ke depan. So it's up to you lah. Okay, I think different people have different learning styles, but generally when I see a lot of students, they like to use the reverse method, and then lepas itu diorang jawab the forward method. Somehow that works for them. Okay, start with the light bulb. Why does the light bulb? I'm not going to repeat that, okay, but but you can watch this video again to see what I mean when you work backwards. Okay, so this is what we call a light dependent resistor as a light control switch. Okay, this circuit is used in automatic street lights. Okay, automatic street lights, if you live in an apartment complex, you will notice that at certain times or at certain weather, suddenly kamu punya lampu di tempat jalan kaki tu kan, dia akan hidup sendiri. Okay, it is not the security guard yang pergi on. You got no time to on your switch. Okay, this is what happens. All right. Now this next part, okay, is a diagram just to show you, okay, which is the, I mean, if you can understand this, it is just a summary of how this happens lah. Okay, let's talk about during the daytime. Okay, during the daytime, now look, the LDR is down here. Okay, so let's talk about this. Resistance of LDR will be low. Okay, daytime resistance is low, light dependent resistor. Okay, so the LDR voltage di sini will be low. So since the LDR voltage is low, the base voltage will be more or less than 0.7. Why 0.7? Because we assume that this is silicon. Okay, so it will be less than 0.7. Okay, base current, will it flow or will it not flow? Of course, it will not flow lah, because the base voltage is less than 0.7. And so if the base current does not flow, IC does not flow. If there is no collector current, transistor switch on or switch off? Switch off. Okay, and if the transistor switch off, the bulb will not light up. Okay, likewise at night. Okay, at night. Now, same thing, look at the position of the LDR. Position of LDR is down here. Okay, so at night, the resistance of the LDR will be high. Okay, so the LDR voltage will be high, will increase the base voltage, become more than 0.7, which is the junction voltage, and that will cause the base current to flow. Base current flow, collector current flow, transistor switch on, bulb will light up. This four is like it's always one after another. Base current flow, collector current flow, transistor switch on, bulb will light up. Okay, it's the same. But now, okay, this is the third one. Now, what if I position the LDR up here instead? I change the space. Okay, let's talk about this. In the daytime, now, when the LDR interchange, now I change this position. Okay, when will this light bulb menyala? Okay, in the day or in the night? Just now we saw that only at night, and if the position is down here, the bulb will light up. So in the daytime, the resistance of the LDR is still low. Definitely that doesn't change. No matter where you put this, resistance of LDR depends on the time of the day. Okay, bukan your position. Okay, and because of that, the LDR voltage will be low. Here will be low voltage. So what happens to the base voltage? Remember the potential divider circuit. Okay, see, this is 6 volts, right? Kalau sini voltage is low, sini voltage will be high. Because there's only a little bit of voltage given here. Okay, so it will be more than 0.7 volts. Now, if the base voltage is more than 0.7 volts, the next 4 things that happen will always follow suit. More than 0.7 volts, more than the junction voltage, base current flow, collector current flow, transistor switch on, bulb will light up. Okay, so this is how kamu punya lampu jalan mungkin boleh turn on pada time siang. Okay, which is like what? Why do we want to turn on the lights during time siang? I'm sure there's a reason. Okay, you change the position of the LDR. Okay, and likewise, at night, okay, you will find that, and this is the most ridiculous lah. What happens at night? What do you expect? It will not light up. Okay, why? Because the resistance of the LDR is high, so the voltage will be high. Sini high voltage, so sini low voltage. It will become lower than 0.7 volts. And because it is lower than 0.7 volts, what happens? Base current off, collector current off, transistor off, bulb will not light up. Okay, these four situations, you have to remember this. Okay, but all you have to do is just remember whether it is more than the junction voltage or less than the junction voltage. Itu saja. Okay. Now remember that the voltage, okay, kalau satu adalah tinggi, satu mesti rendah sebab dia punya jumlah ini mesti sama dengan 6. Okay, so we're talking about in this situation, maybe this is 0.5 and this is 5.5 because the resistance over here is so high. Okay, resistance very high, voltage increase, maybe it's 5.5 lah. Okay, but whatever it is, it will increase so that down here, dia akan menjadi sangat kecil, less than the junction voltage. Okay, so this is an automatic switch circuit. Okay, automatic switch circuit for light-dependent resistor. But there is a second circuit that you have to know, which is a heat-controlled circuit. So a thermistor, we call this a thermistor. Okay, the old name for thermistor is a heat-dependent resistor. Okay, take a look at how the resistor looks like. Okay, the thermistor symbol is like this, resistance symbol with this with this thing over here lah. Okay, which for the life of me, I don't know why they call it that lah. But that's a thermistor. Okay, now a thermistor is a resistor, and the resistance changes with its surrounding temperature. Now this is the ciri, the resistance is high under low temperature. Remember the light just now? In the light-dependent resistor, this is the light-dependent resistor, the resistance is high when it is dark. Okay? Bila dia gelap, resistance is high. Kalau LDR. But in a thermistor, bila dia sejuk, when it is low temperature, the resistance is high. And this is very easy to remember. Kan? Whether it is LDR or HDR, okay, resistance is high when it is dark and when it is cold. Remember this. Okay? Gelap dan sejuk. Okay, when it is dark and when it is cold, the resistance is high. Okay, resistance high means voltage high means no. Okay lah, you know, I mean, if you've already been following since the beginning, you kind of know where this is going. Okay, so as the surrounding temperature increases, okay, the resistance over here becomes low. Okay, because remember, resistance is high when it is cold, but now we're increasing the temperature, so the resistance becomes low and the voltage becomes low. The voltage decreases lah. So kalau di atas sini voltage turun, di bawah sini voltage akan meningkat. Okay, bila dia meningkat, okay, the voltage across the resistor R down here will increase. Bila voltage meningkat, okay, it will be more than the junction voltage. Okay, and then you have the same pattern that happens again. Okay, voltage is more than the junction voltage, so base current flow, collector current flow, transistor will switch on and the bulb will light up. Okay, and so this circuit, okay, this litar is suitable as an automatic switch in a temperature controlled system. Bila dia panas, then dia akan turn on. Bila dia sejuk, then dia akan turn off. Okay, and when is this suitable for us? Okay, this is suitable for us in a fire alarm. Let's say I change this mantle, I change it to a speaker. Okay, I change it to a speaker, and this becomes the circuit for our fire alarm. Okay, bila dia panas, when the thermistor detects high temperature, okay, it's going to decrease the resistance. Decrease resistance, decrease voltage. So the base voltage will increase. Base voltage increase, base current will flow, collector current will flow, transistor switch on, speaker, okay, fire. Okay, thermistor. So what is the characteristic of a heat-dependent resistor or thermistors? Wow. Oh, sorry. Somebody wants to come in. That's odd. Sorry. So the characteristic is the resistance is high when the temperature is low. Okay. So as we said just now, lah. Okay. Sorry. The resistance increases in two situations. Dark. Okay. Kalau dia adalah LDR. Dan cold or low temperature. Okay, kalau dia adalah thermistor. Okay, resistance increases in these two situations. When you remember these two situations, the explanation kan, after a while, I've been repeating this so many times that I feel so bored already. Okay, after a while kan, itu saja itu. Really, it's just that only. Okay, so let's take a look at this. Fire alarm system. Okay, as I said just now. Okay, fire alarm system. Now, let's talk about the first situation, low temperature. Low temperature means like now, no fire. Okay, what happens to the resistance of the thermistor? Remember, resistance of the thermistor is high when it is cold. Okay, so resistance of the thermistor is high. Because of that, the voltage at the thermistor will be high. Okay, so if the voltage at the thermistor is high, let's look at the base voltage. Here, the voltage will be less than 0.7. Okay, the voltage here will be low. This one, the voltage will be high. Because the resistance sudah ubah pergi high. And what happens? After a while, very boring. After the base voltage is less than 0.7, what will happen to the base current? Off. What will happen to the collector current? Off. What will happen to the transistor? Off. And because of that, the alarm will be off. Obviously, you don't want it to be cuaca sejuk and then your fire alarm come on. Like for what? Okay, so we want this to happen. Okay, when it is high temperature, then the fire alarm turns on. Okay, but the thermistor has an opposite effect lah. Okay, dia low temperature, dia high resistance. Okay, macam LDR juga, dia dark. Okay, second situation, high temperature. I'm sure by now, well, I hope that by now you can actually fill this in yourself lah. Okay, without having to refer to this. Okay, resistance of thermistor, when it is high temperature, it will be low. Okay, low resistance. Low resistance means low voltage. Low voltage means over here, voltage will be increased. Okay, the voltage will increase, will become more than 0.7. Okay, and so because of that, tan. Okay, current will flow, base current will flow, collector current will flow, transistor will switch on, alarm will go off. Will go off doesn't mean off, will go off means dia akan ping pong lah. Okay, dia akan bising lah. Okay, which is the best situation that we want. Okay, in this situation. Okay, we want it to turn on when it is high temperature, alias ada api. Okay, and same thing with the LDR just now lah. We want the lights to come on when it is dark. It is a waste of energy if terang-terang macam ni kan, terus lampu jalan pun menyala. Okay, but there are situations lah. There are situations where the lampu will menyala if if it is bright. Okay, for other reasons lah. Another one, okay, if you want to do more research into this lah, another one is the motion sensor. There are some houses they have motion sensor. If they kalau ada orang limpas di depan rumah dia orang kan, okay, and the motion sensor detects it, then the lights will turn on by itself. Okay, same situation. Okay, motion sensor also the same. Okay, of course it depends on another type of resistor lah. Okay, but it works along the same principle. Okay, all you need is the base voltage to be more than the junction voltage. Because once the base voltage is more than the junction voltage, base current on, collector current on, transistor on, alarm or light or menthol will turn on. Okay, now let's do a couple of calculation questions, and then tomorrow we will do the tutorial lah. Okay, so the diagram shows a circuit with a transistor that acts as an automatic switch. The resistance of P, okay, is 50 kilo ohms. Okay, calculate the potential difference. We want to calculate this V. Okay, now there's only one formula in which the transistor circuit applies, besides the one where it says IE equals to IB plus IC. Ini sangat jarang. But when we talk about potential divider circuit, we talk about this formula. Okay, the base voltage equals to R2 over R1 plus R2 times the input voltage. Okay, so we can do the same thing here. So the base voltage is this one, the potential difference across P. So the base voltage, okay, equals to the resistance over here, 50,000 over 10,000 plus 50,000. Okay. Rintangan yang kamu mau guna, rintangan yang kamu mau kira dia punya voltan per jumlah rintangan darab dengan jumlah voltan, which is 9. Okay, 9 volts, yeah. Guys, listen to this. If there is kilo ohms, okay, you need to change it to 50,000. Okay, can somebody calculate for me this, please?
7.5.
Okay, 7.5, can? Am I right? 7.5, huh?
Yes.
Okay.
Yes.
Now, guys, if this is 7.5, you know how many volts is going to run through here. How many?
1.5.
Okay, 1.5. Sebab dia akan terbahagi. Okay, you don't have to use the same formula again lah, you know, but you kind of know. Kalau sini 7.5, sini mesti 1.5. Sebab jumlahnya mesti 9. Okay, that's why we call potential divider. Dia dibahagikan tapi bukan sama rata. Okay, question number 1, determine the potential difference across point X to Z. Sini sampai sini. Kalau the voltage dibekalkan adalah 6 volt, the potential difference across here will be also 6 volts. Okay, so they're from point to point lah. Okay, now the total resistance between point X and point Z, the total resistance is 20 kilo ohms and 10 kilo ohms. Ini kita belajar dari chapter 3. Total resistance in a series circuit is just kasih jumlahkan sajalah. So this will be 30 kilo ohms. Astaga, sorry, 20 plus 10, okay, equals to 30 kilo ohms. Or if you want 30,000 ohms lah, okay, also can. All right. Calculate the current flow through XZ. Okay. Now in a series circuit, the current flow V equals to IR, total voltage, total resistance. So the total voltage is 6, current flow, total resistance is 30,000. What is the current flow?
2 times 10 negative 4.
Okay, 2 times 10 to the power negative 4 ampere or 20 milliamps lah. Okay, very small current. Remember, small current ni, okay, milliamps, microamps, milliamps, actually even less lah, microamps. Okay, now let's calculate the potential difference across YZ. Sini saja. Kita mau kira voltan ini. And this is where we use the voltage divider circuit. Okay, so the voltage of YZ will be equal to 10,000 over, what is the total? 30,000, right? Times 6 volts. Okay, how much?
2 volts.
132 okay, 2 volts. Okay, so potential circuit is very easy. The transistor, this particular subtopic, the calculation part is easy, you know. It is the explanation that you need to master. Okay, the explanation is the thing that you need to master. Okay, but actually, I always say this a lot lah. Okay, transistor, diode, you know, even the apa itu, the AC generator, AC motor, all these things. Once you see it, you cannot unsee it one. Okay, the problem is how to see it lah. Okay, but once you get it, okay, it's like, oh, okay, begitu pula kan. It's not that difficult. It's just getting past that initial stage. Okay, it's the one that will be challenging lah. All right, next question. Now this is a electronic control system. This is a thermistor. Okay, remember the ciri about thermistor. Thermistor means if it is cold, the resistance is high. Okay, this is the important thing. Okay, but here there is also a light dependent resistor. Oh, itu mengada. Okay, there's a light dependent resistor. That means if it is dark, The resistance is high. Oh my goodness. Okay. Now, when light is detected by the LDR here, the resistance of the LDR is 100 ohms. Okay, so 100 ohms. State the potential difference across Y and Z. Again, from point to point is the same as this. So it will be 6 volts. Saya tahu ni, I know why this question is here. This is actually an old syllabus question, okay, which, but the basic is just to get you to count this. Calculate the potential difference across the LDR. Look at the difference in the resistance. Okay, 100 and 3,300. Okay, obviously the light bulb is going to turn on, but let's not talk about this. This is nothing. Okay, but we can calculate the potential difference across this LDR by using the resistance. Okay, so V equals to 100 over the total resistance, okay, 100 plus 3300 times with 6 volts. Okay, potential divider formula is actually very easy. You just have to know mana satu voltan yang kamu mau kira. Okay, yes, how much please?
0.176.
0.176 volts. Yeah, okay, 100 lah. So if this, okay, if this is 0.176 volts, you know how much voltage is flowing here already. Okay, kita kasih tolak lah, 6 tolak 0.176. So you get about 5.834, about, I think so. No, 5.824. Yeah, okay, 5.824 volts. Okay, so again, as I said, the calculation for this is pretty easy. Okay, the potential divider circuit, it is the explanation that is the tough part lah. All right, last question. Figure shows a temperature control alarm circuit. Okay, so the resistance R here has a resistance of 10 kilo ohm. The potential difference across XY must be at least 5.5 volts to turn on the 6 volts bulb. So the question is, what is the resistance of this? Okay, when the bulb lights up. Okay, so this is where the question becomes very tricky. Dia cakap, sini mesti 5.5 volts kalau kita mau ini untuk hidup. Okay, so the question is, berapa resistance di sini? Okay, now if you know that this is 5.5 volts, how many volts is this? Look at the total voltage, 6. So if this is 5.5, this will be 0.5. Okay, and so we can use V equals to R1 over R1 plus R2 times with the total VR lah, V1 lah. Okay, I'm going to call this V1, R1. Okay, this is R2. Okay, and can we calculate R1 from here? We can. Okay, V1 we know is 0.5 because we already determined it by minus. Okay, R1 over R1 plus 10 kilo ohms, so 10,000. Okay, times with the total V, which is 6. Okay, so we can calculate this lah. Okay, we get 0.5 over 6 equals to R1 over R1 plus 10,000. 0.5 divided by 6, please.
1 over 12.
Okay, mau juga 1 over 12. Fine. 1 over 12 equals to R1 over R1 plus 10,000. Okay, let's cross multiply. So you get R1 plus 10,000 equals to 12 R1. Kan? Bawa ini across, 11 R1 equals to 10,000. So what is R1? 10,000 over 11. Oh no, so ugly. 909. 909.0909 ohms. Okay, or basically about 0.9 kilo ohms lah. Okay, very low resistance. Correct lah. Okay, very low resistance because dia sudah panas. Kita mau ini untuk menyala. Okay, we want this to menyala, so it has to have very low voltage. So this is high voltage, base current flow, collector current flow, mental will light up, blah, 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 blah. Okay, but this is how, this is, okay. This one, if anything, okay, I would suggest that you start this question, okay, because because this is a more popular potential divider question. Kan sebelum ini kan kita kira ini kan kira V saja kan. Most of the time, this is the kind of question that they will give. They will give you the V, they will give you the situation where you have, you know, this one, and they will ask you to count the resistance. The most important thing is be very clear, okay, about which resistance you want to count. Okay, and sorry, not just resistance lah, which resistance and which voltage that you want to count. Okay, be very clear about that, and then the potential divider circuit becomes very easy. Okay, so for our next two classes, which I don't think we will need next two classes, but never mind. Okay, for our next two classes, we will look at this tutorial. So it's a good idea for you to prepare the tutorial before our next class so that we can discuss these questions. Okay, no homework for today, but please prepare the tutorial for our class tomorrow. All right.